Alright, so basically right now we're trying to find the value of sine of inverse cosine of x. So I'm looking at this, I see an inverse cosine x, right? So when do we use inverse trig functions? Well, we use inverse trig functions when we're trying to find an angle of some right triangle. So I said the words right triangle, so I think I'm gonna draw a right triangle. So you see, look at this, there's gonna be a pro right triangle. Oh, see, that's beautiful, that's a beautiful right triangle right there, that's like a top 10 right triangle. Yeah, anyway. So inverse cosine of x. So when we use inverse cosine, we're basically trying to find an angle from its adjacent. So basically, suppose we have this angle theta right here, right? If we're trying to find this angle theta, that's not a good theta, I'll fix that real quick. So if we're trying to find this angle theta from its adjacent, from the adjacent side, the hypotenuse, we can say that theta, let me label my sides real quick. Adjacent hypotenuse is the opposite side. That's not 0, that's O for opposite. So if we have all our sides and we're trying to find theta, we can say that theta is equal to inverse cosine of our adjacent side over our hypotenuse, right? That's the definition of cosine, really, adjacent over hypotenuse, so katoa, right? So that's how we find theta, that's how we use the inverse cosine function. So if we have inverse cosine of x, we can do something. We could say that our angle, we could redraw our triangle real quick. Instead of using A, H, and O, right? We could say that this side, is x, and the hypotenuse is equal to 1. Because you can see, our angle is going to be inverse cosine. That's going to still our adjacent over hypotenuse. So it's going to be x over 1, right? X over 1, or just inverse cosine of x, right? So we have a right triangle here. We know that our angle is inverse cosine of x. So our angle is actually inverse cosine of x. So and we have a right triangle, we know two sides. We can use the Pythagorean theorem to find the third side. So, well, we can just do that. That's just using the Pythagorean theorem. We can see that this is 1 is equal to square root of 1 minus x squared. Then we can just do the sine function, right? But we know a triangle, we know our angle, and yeah. So we know sine function, right? Sine of theta is going to be equal to opposite side of our hypotenuse, which in this case is going to be the square root of 1 minus x squared over 1. So it's going to be equal to the square root of 1 minus x squared over 1. So this entire expression is going to be equal to the square root of 1 minus x squared. The dividing by 1 doesn't matter. So yeah, that's basically it. It's just right triangles, right? Honestly. So stay tuned for more cool stuff like this.